Hello and welcome to another How to Math. Today we'll be going over exponent laws. So first I'll be listing the different exponent laws. We have the product rule, which is essentially it can be modeled by a to the power of m times a to the power of n equals a to the power of m plus n. So the bases have to be the same, but the exponents can be added together when they're multiplied. Then we have the quotient rule. So that'll be, again, same exponents, but when we are dividing, we actually subtract the exponents, so m minus n. Then we have the power of a power rule, so power of power. That's pretty much saying a to the power of m to the power of n equals a to the power of m times n. And then the next rule will be power of a product rule. This is power of a product rule. That is pretty much when you have two different variables to the power of something. So what you actually do is distribute. So it'll become a to the power of m times b to the power of m. And this is be power of a quotient. So it's pretty much whenever you're dividing. So power of a quotient. So this would be, when inside the brackets, it is a division to the power of m. So then we distribute again, but this time it'll be a to the power of m divided by b to the power of m. The next exponent law is negative exponent rule. So negative exponent. This is pretty much when you have a negative exponent, so say a to the power of negative m, this will actually go to the denominator to make it positive, so a to the power of m. So these are equal. Next we have a zero exponent rule, so zero exponent. That is pretty much saying that anything power of 0 will always equal 1. That's a very ugly one, just one moment. Yes, so anything with power of 0 will always equal 1. And lastly, we have the fractional exponent rule. So fractional exponent. This is pretty much when the exponent is a fraction, like the name says. So m over n. This is actually where the denominator is whatever the square root or cube root, whatever it is. So we have n here, n's nth root, then a to the power of the numerator m. This could actually also be written as n a to the power of m as well. So these are the different exponent laws that we'll be using today. So we can use these laws to solve the first example. Oops. The first example is let's do x to the power 4 over x to the power 7. So when we have a quotient, so x to the power 4 divided by x to the power 7, we actually subtract. So this would equal x to the power, so 4 minus 7, that would be negative 3, and we can use the negative exponent rule, so this would equal 1 over x cubed. Oh my. 1 over x cubed. So there we go. X to the power 4 over x to the power 7 is equal to 1 over x cubed. And moving on to the next example, we have bracket a to the power of negative x minus 7, bracket a cubed, bracket ax plus 8. So when we're multiplying, we just add all the exponents. So equals a to the power of negative x minus 7 plus 3 plus x plus 8. So when we simplify this, it'll be, the x's actually cancel out, and then we have negative 7, so it'll be 1, a to the power of 4. So this is equal to a to the power of 4. And the last example, this is a bit of a tricky one. We can do this. So we have 3x to the power of 4 y over 9x y to the power of 5 cubed. So in order to solve this, first, I would say we could just simplify the inside. So when we have x to the power of 4 minus x to the power of 1, because it's division, right? We use the quotient rule. It'll be x cubed. So this equals, we can actually simplify the coefficients as well. So it'll be x cubed, and then y, so it's 1 minus 4, so it'll be negative 4. 4 stays on the bottom, so there's no more y on the numerator. This would be 3. X will be gone. So we can actually just do like this, 3. This would be 4, so y to the power of 4 cubed. And then what we use is the power of a quotient rule, where we distribute the cubed to both the numerator and the denominator. So this will become x to the power of 9, because it'll be the power of a power, m times n. 3 times 3 is 9, divided by 3 to the power of 3, so it'll be 27. And then y to the power of 4, and then to the power of 3, that'll be y to the power of 12. So there we have it. It will be x to the power of 9 over 27, y to the power of 12. So this is how we would apply all these exponent laws. And yeah, just stick to these, and you can do any exponent equation, polynomial, simplifying, whatsoever. Yeah, so I'll see you in the next video.